Okay, AMA, we're really introducing calculus. We've got notes on 1.3. First of all, the big learning target is I can solve limits by using my bag of tricks, a lot of algebraic methods to help us. Lots of review from yesterday too and the past few days. First of all, the limit, if you have two functions that are both existing with their individual limits, this would just be f of a plus g of a. You could see that, that relationship would definitely hold true. You can see the limit as x approaches a of f of x and g of x. That would be f of a times g of a. Again, we're assuming that both of these are existing. Here, as we have this, the limit as x approaches a of c of f of x, that would be c of f of a. Here we'd get f of a minus g of a. Here we'd get f of a all over g of a. And even an nth root here, we'd have the nth root of f of a. But with that in mind, we take a look at three quick problems. Dare I say, maybe one of the trickiest things in algebra for some students. Let me ask you this. What's the square root of x squared? Let's be real careful. No, it's not x. It's really the absolute value of x. Now, somebody could say, I strongly disagree. Well, here's my point. What if I gave you the square root of negative 5 squared? What's the negative 5 squared going to be? 25. And then what's the square root of 25? Is what went in what comes out? No. So this is a little thing that calculus teachers really get emphatic about, because a lot of Algebra 1 and Algebra 2 students, kind of think of that, oh yeah, the square root of x squared is x. Actually, no, it isn't. It's the absolute value of x. And then what? Well, the absolute value of x, that's going to be x or opposite x. And it's x if x is positive. When we have something positive, we keep the same thing. When x happens to be a negative number, if we had a negative number in here, then we have to take the opposite of it. So the absolute value function is a piecewise function. Why do I get so emphatic about that? Well, look at this. The limit as x approaches 2 here, you could see that the square root of x minus 2 squared is actually the absolute value of x minus 2. Wow, would you look at that? Would you look at that? That's super important. Hey, you actually get some help reviewing for the quiz right now. You could look at this so many different ways, but let's remember the piecewise definition of the absolute value of x minus 2. Would you agree with me that either we get the same exact thing that's coming inside here or the opposite of it? Right? I mean, that's always the case with absolute value. You either get the exact same thing or the opposite. And then you'd say, well, when do I get the same thing? That's when you are positive on the inside. So what kind of x values guarantee that we have something positive? Greater than 2. Now, by the way, you could even say equal to 2 if you'd like. And then the opposite, well, you'd say, well, that has to be then when you're smaller than 2. Hey, plug in a 1 or plug in a 0 or whatever. You'd see that you get negatives inside of the absolute value. And in which case, you want to have the opposite number come out at the end. So we're bringing this up, real good review. For a limit to exist of this type, let's go ahead and check the right side and the left side. From the right side, when 2 is, actually x is bigger than 2, which assignment up on top are we dealing with, the top or the bottom? What do you think? The top. That's x minus 2 over x minus 2. What do we get? A 1. Hey, we could check what's happening from 2 from the left, but that means we're smaller than 2. So what is the absolute value of x minus 2 then? It's the opposite. Yeah, it's the bottom assignment. And what would this thing work out to? Negative 1. So what would we say about the limit as x approaches 2 of the original problem? Yep, D and E. That's the only thing they're really asking for. They're just asking for this limit. They didn't specify a right side or a left side. We doing okay? All right. You come over to number 2, and if I plug in a 0, I'd get radical 2 minus radical 2 all over 0. I'd get 0 over 0. That's indeterminate. I have to go to my bag of tricks, and I'll say, what could I perhaps do so I wouldn't have that ugly form? Conjugate. Conjugate, right? The reason why you're multiplying by a conjugate is just as important. In fact, it's more important than just doing this. A lot of times kids will say, well, I don't know, teacher told me to do this. I hope it's clear as day that conjugates multiply into squared terms here. A plus b times a minus b is a squared minus b squared. Squared terms get rid of square roots. That's why we're doing this. So, as we work down here, we'd say, well, let's see, up on top, I've got a minus b, and here's a plus b. What does a minus b times a plus b equal? A squared minus b squared. What's a squared? 2 minus t. I'm going to get rid of my radical. Hey, what's b squared? Just a 2. Right? If b is radical 2, when I square that, don't I just have a 2? And down below, I've got a big mess. I've got a t, and then I've got this real ugly expression here. Okay? And I already heard some kids say, don't the 2's up there cancel? You know what? They do. They do. You're right. And, we could write this out and say the limit is t approaches 0. And, you got your t down here. You got all this ugliness. My gosh. And here's a negative 1t. Maybe I'm being emphatic there. Because guess what's about to cancel? The t's. Wow. If you can get rid of your t's here, wow, what's going to be left? You just got negative 1 up on top. And down below, when I plug in my 0, I'm just going to have root 2. What's root 2 plus root 2? 2 root 2, right? Think about it this way. A smiley plus a smiley is 2 smileys. Well, I got to make this guy look the same, right? There you go. That'd be 2 smileys. So root 2 plus root 2 is a 2 root 2. Radicals are okay in a denominator. You could just, leave it like that. Okay? We doing okay? Yes. Could we have factored it? Great question. I don't really see a way to factor that top. You see, that's where you might be forced into multiplying by a conjugate. Don't get me wrong. In a moment, you'll take a quiz. Maybe you'll have a choice there on how you want to proceed. Be aware they might kind of force you to work with the conjugate from now on. Okay? Last one. This was the one that, and it's going to look so bad, but you know what? We got to do this. You've got the ugly, complex fractions. Everybody hates to see this thing, right? We just made the problem look 1,000 times worse. Man, it looks worse. But the bottom line is, when I plug in a 0, I think you can see I'd get a 0 up on top. I'd get a 0 down below. And I don't want to have this. This is known as a classic question, guys. A classic question in calculus. I don't care where you are taking a calculus class, if you're in New York, California, anywhere in between, in a high school, community college, whatever it is, you're going to see one of these, definitely. It's just part of the curriculum, and you just have to know how to clean up a complex fraction. And my suggestion to you is, multiply through by the little common denominator here. You could say, well, honestly, I hate seeing, that fraction within a fraction. If you want to put the 3 out in front, you definitely can do that. But that's what makes this problem a true eyesore when you're looking at it. Look, I'm always going to continue to write my limit. I'm not losing that. But look, as I distribute, what would happen when I'd multiply, just doing some work over here, 1 over 3 plus h times a 3 and a 3 plus h? What's going to happen? What's going to cancel? The 3 plus h's are gone. You just have a 3. And then what's going to happen here when I'm multiplying these? What will cancel? The 3's are going to be gone. And I'll be left with a minus 1 and then a 3 plus h here. And down below, wow, I've got this real ugly, expression down here. I've got an h and a 3. Don't distribute just yet. Your hope is it's going to clean up. Your hope is something's going to cancel. Now, let's clean this up just a tad. We can say, hey, if I distribute this negative 1, I'll get a minus 3 and a minus 1h. And sure enough, you do get some canceling. If you're looking real careful, guys, you can see, wow, this 3 and the minus 3 are gone. It just got cleaned up way better. Does anything else clean up? Does anything else cancel? An h and h right here is gone. Wow, that all of a sudden this is looking way nicer. Up on top, I don't have a 0 anymore. I've got a negative 1. Down below, when I plug a 0 in, don't forget about this 3 out here. That's still there. You have a 3 plus 0 is 3. 3 times 3 is 9. 3 times 3 is 9. So you get negative 1 all over 9.